Woo-hoo. I think we are all set, folks. Woo, this is exciting. So if your RV's air conditioner is not cooling, all right, this is exciting. If your RV's air conditioner is blowing air, but it's not cooling the air at all, then today I am going to give you a quick and easy test that almost anyone can do that is going to tell you with 99% certainty whether or not your air conditioner itself is still okay. Because I know that's everybody's biggest fear. The air conditioner stops blowing cold and they're worried they're going to have to replace the whole unit. This is the test that's going to tell you if you have to replace the whole unit. It's very exciting. All you're going to need is a multimeter, and it can be the cheapest multimeter on the planet. Any multimeter that you buy is going to have the tests that we need today. And if this already scares you, you're getting PTSD flashbacks to that one mean science teacher you had in high school, have no fear. We're going to banish those memories away. I am not your evil high school science teacher. I am your friendly neighborhood RV repair tech. Hi, hello, my name is Emily. I am a certified mobile RV repair tech based in Las Vegas. And this is RV Repair Woman. So let's jump on into it. The first thing that you are going to do for this test is to actually flip the breaker for your air conditioner. So we're going to turn the air conditioner off at the thermostat, turn it to off, make sure it's totally off there, and then throw the breaker for the air conditioner into the off position. One of the great things that I love about this test and why I love having it be one of the first things that you try out with your meter, if you haven't used a meter in a while, is that we're going to shut off power to the thing that we are testing. So we are lowering the chances of getting shocked or interacting with electricity in a way that we don't want to drastically, which is great. Love that. I used to run obstacle course races. Fun fact, that used to be my side hobby. And one brand of them, their like cool differentiating factor was that they shocked you with like 20, was it like 10,000 volts or something like that as one of the end obstacles. And I freaking hated it. When I go and edit this later, I'll maybe pop in the picture of me running through that here. But oh my God, I'm like screaming the whole time, hated it. I will do almost anything to not get shocked, which is great and why I love this test. Almost no chance of it. And we're going to double check the shock factor before we touch anything. So we're going to take the chances of getting shocked from like 1% to 0% there, which is great. All right, so we have turned off power to the air conditioner entirely. Yay. The next thing we're going to do is hop up on our roof. Now, if you're like, Emily, these knees haven't seen the top side of a ladder in years, don't worry, I understand. I have days, I am able-bodied of mind and spirit, and I have days where I don't want to go up on a roof. Find somebody who is young of knee, walk them through this test, then bake them a cookie after. You would be surprised what young people will do for a good baked good. And this test is so simple that you can walk almost anyone through it, okay? So you can make a friend in the process. How exciting. It's so hard to make friends as adults. I'm giving you the way. This is it. So either you or your friend with good knees is going to go up on the roof. They're going to locate your air conditioner. It's going to have a cover on it. Ooh, one moment. Dun, 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 dun. Ba, ba, ba. Cover is going to look something like this. Ooh, ah. If you have a Coleman Mach air conditioner, that cover is going to have 4 screws on the top. If you have a Dometic air conditioner, there's going to be 4 screws along the sides. They're kind of hiding along a lip. Either way, unscrew the 4 screws, shimmy that top off. On these Coleman Mach air conditioners, I find that cover kind of tricky to get off. Just give it a little shimmy action. It will happen. I don't love the design of these for getting that cover off. Dometic did a better job on that. Either way. All right, we got the cover off. The next thing we're gonna do is just, yeah, that's right, this girl's got multicam. We got different POVs going on, woohoo. All right, I'm gonna give you a little tour of what we're looking at here. Ooh, I'm sorry, plant. Over here, we have the fan. That's what moves the air. Over here, we have this sort of black cylinder looking thing. This is the compressor. This is what cools the air, okay? We're gonna test the compressor today because I'm assuming with your air conditioner that the fan's working great. The fan's moving the air. It's just not getting cold. So let's see if this is the culprit. What you're gonna do is you're gonna see that there's this cap on the compressor. There's a post right about here. There's gonna be a nut on there. Unscrew that nut and this cap's gonna come right off. If you have a Klein 11-in-1, that multi-tool that I brag about all the time about how much I love, one of its many different tools is going to get that nut off, okay? So back to the compressor, now that we've taken that cap off, you're going to see we have two different parts here. Now, I am touching things right now because my air conditioner is not plugged in anywhere at all. Yes, not plugged in into anything. So I know 100% there's no power going to this air conditioner. You are not going to start touching anything until we do our test to be 100% sure that there is no power going to this air conditioner. But just for show and tell, I'm gonna touchy because I can. Here on the right, we have what's called the the heat overload. The reason why I got slightly confused is because if you followed a lot of my troubleshooting videos, almost every appliance in your RV has a part that is very similar to this heat overload. So on the water heater, we're talking about like that ECO and that T-stat, if you've seen that video. If you've watched my fridge video and you heard about the thermal disc or the thermal fuse, or you've watched any of my furnace videos and heard about the high temperature limit switch, all of those do the exact same thing. They are a switch that is normally closed, so it normally lets electricity through. And then when something gets too hot, it pops open and shuts everything down. That is all that that heat overload is doing. It is looking to see if this compressor is getting too hot, and if it does, it shuts everything down to not overload the compressor. You can test it with continuity. We're not going to go too deep into that today because we're trying to keep things simple and to the point, but just a little extra bonus tip for my people that have been following along and know how to use their meters. Okay, back on the compressor. So if this is our heat overload, over here is actually the terminals for the compressor itself. What we are going to do first is take our meter. So I'm going to show you how to set it up on the simple meter. I'm actually going to run the test on my fancy meter just because my simple meter's battery is dead. But I'm going to show you this will work with yours. You're going to look on your meter for the section labeled ACV, which stands for AC volts. If you've watched my other electrical videos, you know there's two types of electricity in an RV, AC and DC. The compressor on your air conditioner uses AC power. So if you have a cheap meter like this, it is not auto ranging. It does not know if you're looking for a large amount of electricity or a small amount of electricity. So you just need to tell it roughly how much AC voltage you think you are going to see. In an RV, when it comes to AC volts, the number that we're always looking for is around 120, the same voltage that comes out of your outlets in your house, or the outlets in your RV for that matter. So if you look on my simple meter, under ACV, it has two different options, either 200 or 600. We are going to choose 200 because that's the closest number to 120. We're just telling the meter we're going to see an amount of AC voltage in the realm of 200. We're looking for 120, or in this case, we're going to look for 0, but the number, if it was there, would be 120. You'll see what I mean in just a second. So back to the compressor. I'm going to go ahead and set that up On my fancier meter, if you have a more expensive meter, I'm sure you know how to use it, but just in case, boop. On this one, you're gonna go for the V and then press, oh, and then you're there. You know that you're on voltage AC because of the squiggly line. If you're on DC, that line will be straight. All right, so I'm set to test AC volts. I'm gonna put my meter over here in hopes that you are gonna be able to see it. Whoop. Come on, work with me. There we go, in hopes that you're gonna be able to see the reading on it. You're gonna take one of your probes, put it on one of the terminals of the compressor. You're gonna take the other one and touch any metal part of the air conditioner. And you're looking for a number in the realm of 0, which I don't know if you can see with the glare. See if I can get you a little closer. Ooh, chopstick motion, boop. Yep, 0. Then you're going to touch a different terminal on the compressor and short it to the metal part of the frame, also looking for 0. And then the same thing with the third, still looking for 0. That is going to tell you that there is no power going to this compressor, which is great. That's a good thing. That's going to tell us that we can touch the compressor without getting shocked, which is the big thing we want to see. There shouldn't be any power going to that compressor because we threw the breaker. But on my first ever air conditioner call as a tech, I did exactly that. I threw the breaker for the air conditioner. I went up on the roof to do this exact test and shocked the crap out of myself because it turns out that that RV was wired backwards and the breakers weren't actually doing anything or protecting anything. And they didn't protect me that day. So I learned my lesson on my very first call. Always double check that there's indeed no power going on to what you're touching before you put your meat fingers in the places where electricity might be. So just to show you again, in case you were not following along at home, one probe on the frame somewhere, or one on the case somewhere of this air conditioner, and then one on each of these terminals, one by one, looking for 0 volts. We know we're good, we know we're safe. Then we are going to take some needle nose pliers, and we are going to take off all of the connections on this compressor. Bonus tip, you may want to take a picture of the wiring before you do this, so that way you can rewire it up after if it turns out that your air conditioner is fine. I know how to rewire this because that's part of my job. All right, we're gonna get all of this crapola out of the way. We now have a beautiful compressor just hanging out, living its best life, ready to be tested. Emily, how do we do that test? We're gonna set our multimeter to a different setting. We're gonna set it to resistance. On these simple multimeters, you're looking for this ohm symbol. It's the one that looks like a Greek letter. You might remember it from fraternities and the like. And again, you're gonna have to tell the meter, if you have a simple one like this, roughly how many ohms we're looking for of resistance. Resistance, as a quick reminder, is the number that we use to represent how difficult it is for electricity to move through a substance. So a wire that's just hanging out, living its best life, should have a resistance close to 0. It should be very easy for electricity to move through a wire. Whereas a hunk of wood, for instance, I don't have any right here, should have a much higher resistance because that's why we don't use wood to travel to move electricity around, okay? So we're gonna see if the resistance of this compressor is a number that makes sense. And I'll tell you what makes sense means in just a minute. But if the resistance is too high, that's going to tell us that this compressor has gone bad. So let's go ahead. Again, on this meter, we're gonna have to tell it roughly how much resistance we're looking at. The numbers that we're gonna see here are all gonna be 10 ohms and lower. So on this meter, I'm going to set it to 200 because that is the smallest number available to me there. But if yours had 20, you would set it to 20. and then you'd be ready to go. On my fancier meter, again, just like there's the ohm symbol. I set it there. If I were to just use it like this, it would make a really annoying beeping noise. So I'm just going to hit this orange button to change over from continuity to resistance. If you got the fancy meter, you know what that means. Over to the compressor. What we're going to do, let's see, boom. Can I get that? Yeah, now you can see it. Woo. Don't you move. I see you. Don't you move. Okay. Come on. Come on. You can do it, little guy. We were doing so good. There it is. Okay, boom. You're then going to have your two probes. You do not need to put your meter all the way over here. You could put it somewhere where you can see it, but I'm trying to get you to be able to see the screen. You have your two probes. You're going to put them on two of the posts on the compressor, and you're going to get a reading. Right there it says 1.1. You're then going to touch two other terminals and get a reading there. That's 2.6. And then you're going to touch the last combination of terminals and get 2.8. So if I remember, I got 2.8, 2.6, and 1.0. Go ahead and write all of those numbers down. If I lost you anywhere in there, there are three terminals. We'll call them A, B, and C. So you're going to test across A and B, and then A and C, and then B and C. So every combination of pairs that we can across the three, we're going to write all of those numbers down. Now we're going to have to do just a smidgen of math. Do not get nervous here. Don't be afraid. I've got a tool for you if mental math is not your strong point. It sure as heck ain't mine. Let me figure out where I put my iPad, because that's where I put this tool. So if you are good at mental math, what you're going to do is just add the two smaller numbers together, and they should equal the largest number. Plus or minus about 10% tolerance in there. So smallest number plus second smallest number should equal the third largest number, again, plus or minus about 10% tolerance. Doing that math, when you're up on a roof and it is hot outside and you're sweating, and the answer to this math is going to tell you whether or not you need to replace an expensive air conditioner on someone's RV, can be a little nerve-wracking, which is why I made a quick and easy tool to help me. Literally, all you have to do is put the three numbers in the three boxes. So what did we get? 1.1. I think it was, 2.2 and 2.8. Correct me if I was wrong on my remembering. And it is just going to tell you real easy that this is a bad air conditioner. Because 1.1 plus 2.2, that math I can do in my head, 3.3 is not equal to 2.8, even with that tolerance built in. And yes, this tool does compensate for that 10% tolerance. If you would like this easy math machine that's just going, you could pop the three numbers in and it's just going to tell you whether or not your compressor is good or not, just head on over to rvrepairwoman.com/compressor and I'll email you that tool for you so you can use it to your heart's content. Like I said, I do this all the time and I still use that little spreadsheet just because it makes my life easier. I don't have to worry that I did a mental math error and now all of a sudden somebody needs to spend $1,200 that didn't need to. If your math adds up, so your smallest number plus your second smallest number equals your third number, then your compressor is good. Woo-hoo! That is exciting because the compressor is the only part on your air conditioner that is, or the only electrical part on your air conditioner that is not replaceable. Everything else, the capacitor, the control box, the thermostat, freeze sense, heat overload, all of that we can switch out really easily and really quick. But the compressor is hard piped in, hardwired in. You can't change them out. You're going to get some dude bro on Reddit saying that he did it in some backwoods somewhere. It is not the standard practice. No, your tech is not trying to screw you over by saying they won't switch out the compressor. There's EPA guidelines in there, and the time and the money and the cost of the compressor, all of that, we could not even do that switch out for less than the cost that it would be to get a new air conditioner. So if your air conditioner is bad, you're looking at a new AC. If your compressor is good, then it is most likely that the reason that your air conditioner is not cooling is a very easy thing to switch out and is even easier to test than the compressor. For the compressor, we had to do some math. We had to add two numbers together, see if they equaled a third. We had to do, some pluses and minuses in there. It was a little nerve-wracking for a minute. Almost everything else on the air conditioner, there's no math involved. And you're just using the voltage test just to test if voltage made it into a thing and out of a thing. If you would like to be able to test every part on your air conditioner, step by step, with a mobile tech in your back pocket, walking you through every step of the way, I've created a series of guides, PDF guides, that are going to help you diagnose your air conditioner all by yourself. Right now, I just have them up for Coleman Mach. I have one for if your scenario today, if your air conditioner will turn on, but it's not cooling. And I have another one that's going to be released any second now, that is for if the air conditioner won't turn on at all, where we track down the fan and figure out why that's not turning on. Dometic people, do not worry. I'm looking right over here. I've got a Dometic air conditioner sitting on my floor waiting for me to take pictures for it. Your guides are coming, I promise. These are so much cheaper than any tech that you're going to call, like a tenth of the cost. You get to do the work yourself, so you don't have to worry that some unscrupulous tech is telling you that your air conditioner needs to be replaced when really it was just the heat overload. And my ladies, I see you out there. I hear you. I talk to you all the time. You are nervous about calling a male tech and having them come in and talk down to you and tell you all the things that you're doing wrong in life. I understand there's not enough of us female techs out there. Become your own tech. Be your own expert. No one can talk down to you when you're solving the problem yourself. And you'll have me with you every step of the way with these guides. You can find them at number 4, rvrepairwoman.com/AC guides. Check those out. I think they can really help out a lot of people. Stop trying to dig through YouTube University and hope you can find someone with the answer. I walk you through everything that you need to know. You got this. If a little part of your ear picked up in the beginning when I said that you would know with 99% certainty whether or not the air conditioner needed to be replaced. 1, you're very observant. 2, I still got you. I wasn't trying to trick you. There's only, short of you going under a bridge that was too short and ripping this thing off of your roof and denting the crap out of it, there's really only 2 reasons why an air conditioner unit needs to be replaced. One is what we just tested for, if the compressor is bad. The other is if you have a refrigerant leak or a refrigerant blockage. Unfortunately, leaks and blockages we cannot fix. I don't recommend as a tech that you have someone recharge your fridge. Or your air conditioner. I have a whole reason why, or a whole video on why I don't recommend them for fridges. The reasons are very similar for air conditioners. I will be coming out with a video probably next week or the week after about a test that you can do to test and see if you are in that 1% of people that have a refrigerant leak. It's supposedly, the refrigerant leaks are supposed to only account for 1% of air conditioner calls. I say supposedly because I have not done over 100 air conditioner calls in my span yet. And I've had, I want to say like 3 that had refrigerant leaks, like obvious. This was not me misdiagnosing something. Obvious refrigerant leaks. I don't know if we just have more of them here in Las Vegas, or if I just have an abnormally high number because we just are on the extremes of what these air conditioners are supposed to do here in Las Vegas, but I have seen higher than that 1%. It is still extremely, extremely low. Refrigerant leaks are not common, and they're pretty obvious most of the time when they do happen. You're going to see a black, oily-like substance either on the ceiling inside your RV, so around that access panel for your air conditioner. You'll see like a black, oily substance along the ceiling, or up on your roof, right along here, where the air conditioner is. Again, that black, oily substance is the go-to sign that you have a refrigerant leak. There is a test that you can do to test electrically to see if you have a refrigerant leak. It does involve having a meter that has an amp clamp on it, which isn't something that you find on these super cheap meters. And this is the hump that I'm trying to get over most people. But again, I'll have a video coming out soon on how to test that. So you can test to make sure you're not in that 1%. But if your compressor is testing good, you can know with 99% certainty that your problem is upstream. And that's a super good thing that you want to see, because it means you can solve that problem by yourself. Real quick, real easy to change out, and we can get your air conditioner back up and running real soon. I think that is all for today. In the meantime, please consider hitting subscribe. I put out videos like this on the regular, giving you the RV tips and tricks that most techs don't want you to know. I'm trying out a new kind of format here, trying to find a way to get these videos out as my business gets busier and busier. Summer is coming. That's like when I am just trying to crank out as many calls as I can during the day, because that's the busiest time of year here, which is why we're trying something out with the multi-cams. And seeing if we can't get these videos out consistently for you. My name is Emily. This has been RV Repair Woman. You got this. Ah.